motion, physics class level. So we will be continuing our discussions on friction. So what we have seen in the last class, I am trying to give you a summary of it. So there is a condition of solving this problem. First is you will draw the FBD, free body diagram, neglecting friction. Okay, friction, and calculate the normal force, friction, and calculate the normal. Why are we doing that? It is to check whether the body is moving or not. So it's the other way around also. We need to first check whether the body is moving or not. So for that, what will you do? Draw the free body diagram. So first we will do this thing. So we will draw the free body diagram and neglecting friction and calculate the normal force. Then what you will do is calculate F max. Calculate F max, that is limiting friction. And then if F max is greater than net force, then body is in rest. And F max is greater than less than net force, then body is moving. Okay. So what are we supposed to do? First point is check whether the body is moving or not. Okay. I need to check whether the body is moving or not. So for checking that, what will I do? First, I'll draw the FBD of the body, neglecting friction. So draw the free body diagram of body, neglecting friction, and calculate the normal force. Okay. So normal force is how we are calculating. We are equating the vertical direction forces because there is no motion in the vertical direction, and that's how you vertical to the surface of contact. Okay, you will be thus calculating the normal force, and then you will calculate the net force. Okay. I mean, net force you will be you will calculate using what? Like if this is a inclined plane, this is the block over here. Why I'm choosing inclined plane is because I want to show that whenever you're calculating normal force, it's perpendicular to the direction of surface of contact. Contact surface. So this is like this block is there. It's 1 kg block. 1 kg block is here, and because of this 1 kg block, there will be a 10 Newton acting here. So you can resolve this into parallel horse parallel to the surface and perpendicular to the surface. You can resolve this, and this perpendicular component will be opposed by normal force, and this is and you can calculate the net force using the horizontal component of the weight. Okay, that's how it will be like 10 sine whatever theta is here. We'll take that theta. Okay, and then this is 10 cos theta. So n equal to 10 cos theta you will be getting, and using that you can calculate F max equal to mu n. Then you can calculate the net force like force equal to 10 sine theta minus mu n, and you can check whether the net force is 10 theta is there, and if net force is larger than F max, then the body is at rest, or is F max is smaller than net force, then the body is. When you're thinking about friction, then if you're taking net force equal to 10 sine theta minus mu n, then if it is non-zero, then the object is moving. If it is zero, then the object is not. In that manner also you can think about it. Okay, so if body is moving, you will consider kinetic friction, and if body is not moving, you will consider static friction. Okay, that is how we have explained the problems in our previous lecture. Now we will see one problem. So this is how we are calculating this is the angle here. So there is a block over an inclined plane. We are taking this inclined plane having a rough surface with mu as the coefficient of friction. So mu is there means the rough surface. Rough. Okay. So this block is having a mass of m, and here it's a fixed surface, fixed inclined plane. The inclined plane is having an inclination of angle theta. Now you need to find acceleration a, okay, of the block. So how will we proceed with this problem? First, we have to draw the free body diagram. So how are you going to do that? This is the inclined plane. This is the inclined plane. This is the block over the inclined plane of mass m. It will have a weight mg acting downwards. And you have to resolve this into perpendicular and parallel components. This is mg, and this is the perpendicular to the inclined plane direction. This is parallel to the inclined plane direction. So mg will have two components. This is the angle theta, right? This is angle theta. So this will be theta. This is mg cos theta. This is mg sin theta. Okay. And due to this weight vertical component, there will be a normal reaction. And they have given something like, we will do one thing. So there will be friction acting over here, right? Because there is this some forces trying to pull this block down the incline. So there's this friction acting over here. Okay. And if at all there is some kind of acceleration here, we need to calculate that. Okay. Acceleration equal to question mark. Now what are we supposed to do? We will equate the perpendicular direction to the inclined plane and parallel direction. So perpendicular direction, vertical will give you n equal to mg cos theta. Okay. And F max we can calculate using mu times n is equal to mu mg cos theta. Okay. Now we need to do what? We need to calculate the net force. So how are we calculating the net force over here? So I'm taking it as the maximum force or something. Okay. So net force, which is trying to pull this block downwards, is net force equal to mg sine theta, and this F, I am taking it as F max. Okay. Minus, so minus F max is what? Mu mg cos theta. Okay. So this net force is trying to impart this mass times acceleration, right? The net force equal to mass times acceleration. Net force is what? Mg sin theta minus mu mg cos theta equal to m times a. M and m cancels. So it's like a equal to g sin theta minus mu g cos theta. Okay. So this is the acceleration of the block kept on a rough surface, rough inclined surface. Okay. You can see that the mass of the block, it doesn't, the acceleration of the block does not depend upon the mass of the block. So what contributes to the acceleration? The angle of the inclined plane, and mu. So if the surface is very rough, that means the mu value is higher, then the acceleration will reduce. The acceleration is lower when mu is larger, and depending on theta, it's like as per the same. I mean, the cos theta and negative theta both has theta value in it. So if theta increases, then sin theta will increase. So this d sin theta will increase, and if theta increases, this cos theta will also increase. It has a relative kind of dependence when it comes to theta value, acceleration in theta. But mu has a significance in acceleration. How? Like mu, if it is increasing, this mu g cos theta value will increase. That will be subtracted from sin theta value. So acceleration will increase. Now next problem we will see. It is like so if I'm taking these two values, okay, these two blocks are here, and I'm saying that um, so first question you can ask is like why there are two mu values for the surface. I am considering two blocks. Okay, the surface which is in consideration is like there are the block, the surface of the block and the surface of the inclined plane is coming into contact. So if I'm considering two different blocks, then the block one will have a different surface and block two will have a different surface. The pair of surfaces being formed between block one and inclined plane and block two and the inclined plane, both are different. So that's why I've taken mu as two different values over here. Okay. And you can see for block one, what is happening? Block one, mu is larger, so acceleration will be smaller. Block two, mu is smaller, so acceleration will be larger. So what will happen when two blocks are sliding down this incline? So since the block one is having a smaller acceleration than block two will speed up and collide with block one. And eventually both of them will be sliding down together. So that is when this the smaller block with larger mu will be having a smaller acceleration, and the smaller acceleration will be the common acceleration of both the blocks. Okay. What if it was the other way around? For example, here this block one is having this is block one, this is block two. So block one is having mu, smaller mu, so acceleration will be larger. Block two is having larger mu, so acceleration will be smaller. So they won't collide with each other because this will have a higher acceleration than this one. So second block, so it will speed up and reach down first, and then the other one will be coming. So both of them will have different acceleration, A1 and A2. So we will try to solve this problem. The first one will be like first we will solve this problem. Okay. So what are we supposed to do? So this is 0.3 mu is there, 0.2 mu is there between 2 kg and 4 kg, and you need to find the acceleration of both the blocks. Okay. So what are we supposed to do is, this is the inclined plane, and we will draw the free body diagram of 4 kg. Okay. So we are considering a collision between these two blocks, right? So when these two blocks collide, there will be a reaction force between these two blocks. Okay. So what we will do is, we will draw this reaction force over here for 4 kg, and weight of the block is for 40 Newton, and this is the perpendicular and parallel components of the force. This angle given is 30 degrees. So this will have 30, sorry, cos 30. 30 is root 3 by 2. That is 30. Sorry, this is 40, right? So this 40 Newton component we are talking about. That 40 cos 30. So 40 is 40 root 3 by 2. That is 20 root 3 Newton. And this side it is again 40 sine 30. That is 20 Newton. Okay. And there will be a normal force over here, and there is a frictional force here. Okay, so what will happen? Normal force we can equate first. Normal force is what? Normal force will be equal to 20 root 10. So F equal to mu is 0.2 times 20 root 3. So that will come here. 6 root 3 will come here. 6 root 3 Newton. And we will equate this net force equal to mass times acceleration. So net force is what? R plus 20 Newton. So that is what is pulling this block downwards. R times R plus 20 Newton equal to mass times acceleration. Okay, R plus 20 Newton. And there is this frictional force which is acting upwards. 6 root 3 is equal to mass is 4 kg and acceleration is A. That is equation 1. Similarly, for the second block, we can again draw the free body diagram. So this will be 2 kg over here. So the values will be like, so this R is in the opposite direction. You can see after collision, 4 kg is exerting this R value over here. So R is over here, and weight of the block is 20 Newton. So this will be 20 cos 3. I will write it over here. So this is 20 Newton. This is 20 cos 3, which is equal to 10 root 3. And this will be 20 sine 30. That is 10 Newton. And friction will be different again. That will be, okay, we will equate it. This is block 1. Block 2 is block 2 is n equal to 10 root 3 Newton. So F equal to point, here this point, I wrote it wrong. The value is correct, 0.3. So this is 0.2 times 10 root 3 Newton. is equal to 2 root 3 Newton. So second will be like net force equal to mass times acceleration. Net force is what? Net force is 10 Newton minus 2 root 3 minus R equal to mass times acceleration. This is equation. Okay. So adding this two will get rid of this R term. So equation 1 plus equation 2 will give you R plus 20 minus 6 root 3 plus 10 minus 2 root 3 minus R equal to 4A plus 2A. So this R and R gets cancelled out, and the remaining will be 20 plus 10 is 30 minus 6 root 3 plus 2 root 3 is 8 root 3 equal to 6A, and A equal to 30 minus 8 root 3 by 6. 30 minus 8 root 3 by 6 equal to approximately, okay, so that is equal to 2.6 meter per second square, the value. Okay, so that is how we calculate the acceleration. The key point here is you understood that mu of block 1 is larger than mu of block 2. That means acceleration of block 1 is lesser than acceleration of block 2. So this two will collide and it will move with the same acceleration downward. So that's why this A and this A, we have taken it as the same one. Okay. That's why it's very easy to solve this thing, because we have got two unknown values and two equations. We can solve it. Okay. So that is what has made this problem easier. Now the other way around, what if mu of the second block is larger than mu of the first block? So we will try to calculate that over again. So here we know that mu of block 1 is lesser than mu of block 2. So so acceleration of block 1 will be larger than acceleration of block 2. So the block 1 will speed up and go down the inclined plane ASAP, and block 2 will be following it. So there won't be a collision. So acceleration of block 1 and acceleration of block 2 is going to be different. Okay. So we have to calculate both the acceleration now. So how are we going to do? So here this reaction force is not coming. Why? There is no collision. So two values, two equations, we will be getting it. So two values are like A1 and A2, acceleration 1 and acceleration 2, and you will be getting two equations from two free body diagrams, and it's very easy to solve. How to do it is either you can draw the free body diagram and you get this value, or else you can directly use this equation, A equals to G sin theta minus mu G cos theta. You can directly use this value equation. Yeah. So how will you get this thing? So for block 1, A1 equal to E sin 30 minus mu is what? 0.2 E cos 30. So A1 equal to 10 sin 30 is 1 by 2, and 0.2 10 cos 30 is 3 by 2. So solving, you will be getting what? 3.3 meter per second square. Second block, you will be getting A2 equal to G sin 30 minus mu is 0.3 times 10 times root 3 by 2. So you will be getting what? 10 times 1 by 2 minus 0.3 times 5 root 3 is equal to 5 minus 0.3 times 5 root 3 is equal to 2 point 2 point, uh, 2.45 meter per second square. This is how you can calculate. Otherwise, you can draw the free body diagram and find this expression for both of it, and you can substitute and find the value. Now, another problem is retardation of the block. Okay, so how are you going to find the retardation of the block when this block is initially being pushed by a force, and then after some point of time, due to the roughness of the inclined plane, it is going to stop. Okay, so let me say this problem properly. So this is like an inclined plane with an angle of inclination of theta, uh, having a rough surface uh, with a coefficient of friction mu is there, and a block of mass m is uh, at the bottom of this inclined plane, and with an initial speed of u, it is being pushed upwards. Okay, so with an initial speed of u, this block is pushed upwards, and you need to find the retardation. So retardation is caused by what? Friction force, which is being provided by the rough surface of the inclined plane. So we need to find the frictional force first, and then with that frictional force, you will find the active, retardation. So what will you do? First, you will draw the free body diagram of this block. This is the block. Okay. It's m of mass m. So m is the weight acting downwards, and you can resolve this weight into its two components. One is perpendicular to the surface, and another is parallel to the surface. And this is having an angle theta. So this is mg cos theta, and this is mg sin theta. And because of this mg cos theta, there will be a normal force acting upwards, and there will be a frictional force. Okay. Now, frictional force here. So that is the key point over here. Now you should understand, I'm trying to push this block upwards. Right? This is the movement direction. Friction will always oppose the movement, right? Friction will always oppose the movement. So, which will be the direction of friction? Friction will act towards the uh, opposite direction of movement. Okay. And initially, we are giving a velocity u to the block. So, what will be the friction over here? That will be a kinetic friction. Why? Because there is a relative motion between block and the surface. So we can equate all this thing together. So one is right, normal force equal to mg cos theta. Why? Because there is no vertical motion. So whatever is like in the same direction will counter each other. So n equal to mg cos theta. Fk equal to mu k n, that is mu k. Mu k is not there. Mu k is mu here. Just given as mu, right? So mu mg cos theta. So this net force is what now? Net force is both of these are acting down, right? Net force is what? Net force equal to the horizontal component of weight plus Fk. is mg sine theta plus mu mg cos theta. Okay. Now net force equal to mass times acceleration. So mg sine theta equal to mg sine theta plus mu mg cos theta equal to mass times acceleration. So acceleration equal to m gets cancelled out, g sine theta plus mu g cos theta. And since it is opposite to, so if you're taking u as positive, then a is negative because it's opposing the motion. So that is the retardation over here. Is this similar to what we have calculated earlier? No. Why? Because here the frictional force is acting upwards because the impending was downwards. That's why you were getting this negative sign. Here the motion is upwards, so this frictional force is actually aiding or helping the gravitational force. I mean, it's in the same direction. And so two things are trying to decelerate this object. One is the gravitational force. So without friction also, g sine theta is trying to pull this block downwards. Because of this initial push, this block will start moving at the velocity, and this block will slowly start to decelerate because of this gravitational force, g sine theta. Okay, and this u will, after some time, this block will stop. It will become, after coming somewhere here it will come, then this u will become 0, or v, another velocity will become 0, and at the next instant it will start moving downward. Okay, but imagine this thing. Okay, this block is moving upwards with the speed of u. Now there is something called friction is also there. Because of the motion is upward initially, frictional force is also acting downwards along with gravitational force. So both of them together will decelerate. And what will happen is, now, since we are considering friction also, the distance traveled by this block before stopping will be somewhat nearer to the end of this inclined plane. Won't reach that much height. Okay, it will reach somewhere here and it will stop. And the next instant it will start moving downwards with u equal to a non-zero value. Okay, a small velocity will start going downwards. Now what will happen? Gravity is trying to assist this downfall. So g sine theta is pulling it downwards. So this will start accelerating. But along with that, what will also happen? Since the movement is downwards, friction will now oppose this motion. So friction will start acting upwards. This direction, friction will start acting. So now g sine theta is trying to accelerate and mu g cos theta is trying to decelerate. That will be this condition, right? And eventually, depending on the mu value, it will come to a z acceleration, and then it will reach downward again. Okay, that is how this problem works. Now the next one will be finding the distance traveled by the block before it stops. So this has become a rectilinear motion problem now, or uniformly accelerated motion problem now. So what will we do now? We have found the retardation, right? So retardation, can you use any uniform motion equation to find distance? So this is like, this is initial speed u, then it will travel a distance of, sorry, will reach somewhere here, this block, and this distance that is traveled by this block is taken as s, and after reaching here, it will become v equal to 0. Okay, now acceleration A is happening in this direction. This is not acceleration, retardation, but I have mentioned the direction. So you can use something like this: v square equal to u square plus 2as. So a we have calculated here. We can use this a here. So v square, v is 0, final velocity is 0, the velocity is u square plus 2 times a is what? Minus e sin theta plus mu g of theta times s. So s you can find it as u square by 2 e sin theta plus mu g of theta. So this will be the distance traveled by the block before it comes to rest. This problem had only one challenge, that was calculating acceleration. After that, it was just a direct use of the uniform motion equation. Okay. Now another question is, okay, here coming to this string pulley problem. So the question here is, there are two blocks over here. One is M1, another is M2. It is connected over a string, over a pulley. We need to find the acceleration of this block. We need to remember, okay, revise the pulley string problem. And the key concept here was, over the same string, tension will be the same. So this is the tension force in the string. Since the same string is going over the pulley, again, the same tension force will be there here. So tension force is countering what? This weight of this block. And the weight of this block is acting downwards. And normal force is here. Okay. Now the only change here is, this is a rough surface with this coefficient of friction mu. Now you need to find the acceleration. Since the same string is going over this pulley, acceleration of M2 will be equal to acceleration of M1. So you need to find only one acceleration value for both the blocks, right? Now we were saying like, okay, this, due to the weight of this M2, there will be tension on the string, which is transferred through the string till M1, and this tension is trying to pull the mass M1, and because of this roughness here on the surface, there will be frictional force acting, which is equal to mu times n, right? So this we will draw FBD of M1. This is M1. It has got M2. So this has got M2G, and this has got T equal to what? And I'll write it down. T equal to what? T equal to M2G. You got that. Now of FBD of 1. So here M1 is there, N is there, E is there, and friction is trying to oppose this T. So N equal to M1 T, F equal to mu times N, that is equal to mu M1 T, and T equal to M2G. We have found that. So the net force, what? Net force over this block is equal to, net force equal to T minus F, that is equal to M times M1 times A. Okay. Or in another way, you can say you can form two equations going here, right? One is for block 2. Block 2, what will happen? Net force equal to mass times action. So M2G minus T equal to M2A. That is equation 1. Here it will be like T minus mu M1G equal to M1A. That is equation 2. Now you can remove this by adding this to equation. So that will be M2G, equation 1 plus equation 2 will give you M2G minus mu M1G equal to M2A plus M1A. So that will be equal to M2 minus mu M1G equal to M2 plus M1. So A equal to what? M2 minus mu M1G by M2 plus or M1 plus. That is the acceleration of two blocks in the pulley using a spring. Okay. Now another question. Here like two blocks are under consideration. This is also a rough surface with coefficient of friction mu. Okay, both are having the same roughness. Okay. I'm taking the same mu for both the surfaces. We need to find the acceleration. Okay. So since all the blocks are having the same mass m, first we will be doing what? This due to this mass m, there will be this weight mg acting. Because of this, there will be tension here. Because of this, there will be tension here. And because of this, there will be a tension here. So that is done. Right. Okay. Here, this is a different string between these two blocks. So we will take different tension over here. Now, because of this block, there will be a weight here and normal reaction here. Because of this block, there will be another weight here and the normal reaction here. And all of this are moving at the acceleration A. And now comes the celebrity. What? Friction. So A is moving like this. So it will be here. Okay. And here also there will be friction. Okay. Now what will you do? First we will draw the free body diagram of block 1. Block 1, this is block 2, this is block 2. PD1 will be mg and T. So net force equal to mg minus T equal to m times A, equation 1, and T equal to mg. Okay. Now FPD2 is like this. T is here, T dash is here, mg is here, n is here, and friction is here. So friction is what? Friction is mu times n. Friction is equal to mu times n. N equal to mg. So mu mg. And so the equation will be T minus T dash minus mu mg equal to ma. That is equation 2. Then FPD3 we will be writing. FPD3 is again here F is there, here T dash is here, N and mg. So the equation will be T dash minus mu mg, because this F was also mu mg, equal to ma, equation 3. Now all the equations together, if we add, you'll be getting mg minus t plus t minus t dash minus mu mg plus t dash minus mu mg equal to 3 ma. So this t and t gets cancelled, this and this gets cancelled, all the m can be cancelled. Now you'll be getting what? So you'll be getting g times 1 minus 2 mu 2 mu equal to 3a. So a equal to g times 1 minus 2 mu 5. That is the axis. Okay. So that's done. Now the next question. Find the acceleration when two blocks are connected over a spring over a pulley which is placed on a inclined plane. Now, how to calculate this thing? So this is like one is M1 is there, M2 is here. Okay, rough surface, so it has a um, coefficient of friction as mu, and theta is the angle of inclination. So because of this M1, we'll have this weight is there. This is having M2G acting downwards, tension acting upwards, this tension pulling this block, and this will have a component M1G cos theta. This will have a component M1G sin theta, and another normal reaction here. And since this is kept over a rough surface, what will happen? There is friction acting to oppose this motion of this block upwards. Okay, now we will draw the FBD here. FBD 2, this M2 block, M2, M2G, and T equal to M2G, and sorry, T. So the equation will be, and it is moving down. So T minus M2G equal to MA. That is equation 1. And FBD 1 is what? This inclined plane thing. This is the block. This is M1. This, so M1 acting downwards. M1G cos theta, and N is there. And then you have this M1G sin theta, and F is acting like this, and T is acting upwards. Now, when you solve this, equate this, F equal to mu times N equal to M1G cos theta. So, mu M1G theta. Now, M1G sin theta, so T minus M1G sin theta minus F equal to M1A, M2A. Now, substitute for F, 1G sin theta minus mu M1 cos theta equal to M1A. That is equation 2. Now, equation 1 plus equation 2 will give you T minus M2G plus T minus M1 Wait. So there's a slight mistake over here. So M2G is larger here. That's why it is going downwards, right? So M2G minus T equal to M1, M2A. That's why it is not getting. Now it will M2G minus T plus T minus M1G sine theta minus mu M1 cos theta equal to M2A plus M1. Now this T and T gets cancelled. So the equation will become like M2 minus M1 sine theta minus mu M1G theta equal to M2 plus M1 times A. G you will take it common. G times M2 minus M1 M1 sine theta minus mu M1 cos theta equal to M2 plus M1 times A. A equal to M2 minus M1 sine theta minus mu M1 cos theta times G by M2 plus M1. That's the acceleration. Okay, so that's all for today's class. Thank you and have a great day.